Okay, continuing on problem 20C. Step 3 are calculations. Now the worst part about doing all this for me remotely is that I've got this small rickety board to do all this on, and so I can't fit everything. So I just built part of the table over here for us to put the answers in, but we know we would need the full table, but if I put the full table on, there's no room to do any of the math. So we're just going to show the table a little bit at a time on here. So again, we can, some people like to do the total value and then the two parts. Let's just go straight down the column. It's just more straightforward that way. So we're going to start by calculating our sums of squares between treatments. So look at your formula sheet handout, and we see the formula for that is the summation of t squareds over little n minus g squared over capital N. So what does that mean for us? Well, when we look in our data, we see that the first, oops, lost my place, the first treatment total was 6 points. We had to figure that out on our own. So it's 6 points squared. And how many scores are in that group? All the groups are the same. They all have 6 folks in them. The second group's treatment total was 12 points. Also 6 people in it. Remember, these numbers in the bottom could be different. This problem just happens to have them all the same. And our last one was t of 36. Oops, not equals, just add. 36 squared over 6. And then lastly, we want to get the g squared over the capital M. So the book told us that g is 54. And the total number of scores is 6, 12, 18. Now notice there's a double checking of math we could do here. 6 plus 12 plus 36 needs to equal 54. The problem told us the grand total is 54 points. So these things need to add up. So 36 plus 12 gives us 48, plus another 6 gives us 54. We know our math worked out there. So square this, then divide. Then square this, then divide, square this, then divide, square this, then divide, and then fraction plus fraction plus fraction minus fraction. What you should get when you do all that is 84 points. So again, what I recommend you do here is we move through this, pause the video, grind the numbers, see if you can't make it come out to 84 points. So remember, it's all separate fractions. Figure out what this fraction is first, then that fraction, then the next fraction, then the next fraction, and then add, subtract, and you'll get 84. So we're just going to write the number right in our box there. So the first calculation is done. The next thing we want is our sums of squares within treatments. So again, look at your formula sheet. And we see that simply taking up the sums of squares values for each treatment and adding them together. So these values are given to us. For the first group, sums of squares is 120. For the second group, sums of squares was 130. And for the last group, sums of squares was 80. So literally all we got to do is add 3 numbers together here. 120 plus 130 plus 80. And what we get is a total of 330. Now, if we know that the first part is 84 points and the second part is 33 points, if we just put those in our calculator, 84 plus 330, 414 is the value we see there. When we calculate this, it had better turn out to be 414 or we've done something wrong. Again, we don't want to just assume these are correct and write a number in there. We want to use this to be able to double check ourselves, not to take shortcuts. So, our sums of squares for the total study we know is the summation of raw scores squared minus G squared over capital N. The summation of all the squared raw scores has been given to us in the problem. The problem tells us it's 576. Again, if we already had written down our G squared over capital N, we'd already have that done. But otherwise, we've got to recalculate it. So that, again, that's 54 squared over 18. So again, resolve this fraction first. Square your 54, divide that by 18, and then subtract that out of 576. And what you should find is that indeed it does work out to be 414 points. So our first column of calculations is complete. We've done all three calculations and we verified that everything adds up correctly. So more than likely all these answers are correct. Now we need to go to the second column, our degrees of freedom column. Again, this is a pretty, math-wise, this is a pretty easy column to take care of. So the first thing we want is our degrees of freedom between treatments. So we need our degrees of freedom between treatments. We look at the formula sheet and we can see that that's K minus 1. We know that that is, K is 3. So a 2. That's going to be a pretty common result. We'll see some other problems sometimes that are different from that, but that's often going to be the case because we're usually dealing with 3 treatment groups. Next up would be our degrees of freedom within treatments, which we know is simply the summation of degrees of freedom. Well, how many people are in the first sample? We can see that 6 are. So what's the degrees of freedom? 6 minus 1 is 5. And 5. And 5. So our degrees of freedom within treatments is 15 points. Now again, before we make the degrees of freedom for total, let's look. We've got a 2 in the top box, a 15 in the second box. 2 plus 15 is 17. So when we calculate our degrees of freedom for the total study, it needs to come out to be 17 or we've got a problem somewhere. Well, we know the total number of scores in the study is 18. And sure enough, we wound up with a 17. So now we've got the second column done. And when we've double checked our math and we see that that's all correct. Now we can go to the third column, which is our mean squares column. Again, just a reminder, mean of squares is just a new way of saying variance. So calculate our variance between treatments and our variance within treatments. And remember, we don't need to calculate the total variance. We could calculate it, but it doesn't help us solve the problem, so we're not dealing with it. Again, I wish I could have the whole table up there at once. Maybe I'll put it all up there when we're done calculating, which we're pretty close. So our mean of squares between treatments is your sums of squares between treatments divided by your degrees of freedom between treatments. So your mean of squares between treatments, our sum of squares between treatments we calculated was 84 points. See that in the very top left box, the first one we did. The degrees of freedom between treatments, we just looked at a second ago, was 2. So 84 divided by 2 gives us 42. So our variance or mean of squares between treatments is 42 points. Now we do the same thing again for within treatments. All we have to do is change all these little b's into w's. So our mean of squares within treatments is our sums of squares within treatments divided by degrees of freedom within treatments. Again, we get those from the preceding 2 columns. So our sums of squares within treatments is 330. Degrees of freedom within treatments was 15. So 330 divided by 15 gives us a result of 22. So our mean squares within treatments is 22 points. And now we only have one calculation left. You see how that prep work just makes this zip along, basically. Our last calculation is for the F ratio itself. Remember, that kind of attaches to the right-hand side of the table. So we're going to see... So our F ratio is our variance or mean of squares between treatments divided by our variance or mean of squares within treatments. So we just calculated those two values. Our mean of squares between is 42. Our mean of squares within was 22. So when we divide that out, we end up rounding this to 1.91. So again, even right here, we're going to report the degrees of freedom with it. Always, always, always. Between and then within. So we have an F of 2 and 15 that equals 1.91. And that's just how we say it. An F of 2 and 15 equals 1.91. So step 3, all done. We've got all the calculations done in there. Now we can back up to step 2 and look at what our critical F was going to be and make our decision. We will tidy up the rest of this in the last little video clip we'll put together here.